Welcome to the whitchermath channel and my technology experiment with my new Hovercam Flex and Screencast-O-Matic. We'll see if this is an upgrade or a downgrade from previous modes of recording. Anyway, today we're working on part 1 of 4 of a transformations series. We're going to start with the translations. Here's straight from our notes the other day in class. What is a translation? Well, a translation you may have previously learned as a slide. It's when you slide an object horizontally this way or vertically this way or both. Okay? Horizontal refers to x coordinates and vertical refers to y coordinates. Let's get down to business here. In my thumbnail for the lead into this video, we had the location A, which is our beginning location. Start here. And B is where we end up, ending location. And to get this shape from that location to that one, I went x plus 5, y minus 3. Let's do a couple of examples here, okay? If we start with the shape, always look for the start. By the way, here's the vocabulary I'm hoping to cover in this very short video, what hopes to be a short video. Here's location A, and here's location B. Let's start with an easy one. What translation happened here? Well, you might say it slid 2 spots to the right. Now that's great casual language vocabulary, but a couple things here. First of all, it's wrong. And second of all, we want to use more academic language. So we're going to use words like, here, let me drag this up here. Nice. Okay. It slid horizontally, meaning it went that way, which is parallel with the x-axis. Okay, so it's moving the same direction as the x-axis. And let's understand why 2 spots is wrong here. We're going to choose a vertex. A vertex is any spot where 2 lines come together. In this case, I'm choosing that one. And there's the corresponding vertex. Same relative place on a similar congruent shape. Okay, that's in the same spot on both shapes. Very easy to see here. Now if I ask, well, how far did that corresponding vertex translate? Well, it went parallel with the x-axis, so it's a movement of x. And since it went to the right, right equals plus, left equals minus or negative movement. Okay, just like when you're graphing. So how far did it go? 1, 2, 3. It moved 3 spots. So the way I would actually say this is we translated x plus 3. That's the technical talk. That's the language we're going for. After all, that's the title of the video, okay? So we translated x plus 3. Let's take another example here. I'll take the same shape. I kind of like it. Okay, there's location A. I love that I can just drag this around without actually moving my paper. Crazy. Okay, I'm going to take shape A, and we want to translate it down here. Go ahead and tell me what happened here using our academic language. What happened? What? I can't hear you. Right. It translated up and down. Yeah, that's vertical. Yeah. Right. Okay, because you found a vertex. Okay, here we go. I'm going to pick a vertex here, and I'm going to identify the corresponding vertex, and going to see how far that went. Well, it looks like it went parallel with the y-axis. So we translate y. Did it go up or did it go down? Of course it went down. So it translated y minus, and then we go 1, 2, 3, 4, 5. Y minus 5. Okay, so we went parallel with the y-axis. We went down, and the corresponding vertex moved 5 spots. Okay, now let's do one where we do both types of movement. Let's see, I'm going to go here. Watch out, I'm making a bigger one this time. Okay, so in our first example, we did horizontal movement. In our second example, which I need to drag over here. Whoa, whoa, hold on. We did, oh no. There we go. In our second example, we did vertical movement. And now in our third example, we're going to do both. Okay. So to get from A to B, what happened? Well, of course, we translated because that's what this video is all about. I'll give you a second to think here. First, we need a vertex. Nice. Then we need a corresponding vertex, so we can do some tracking here. Oh, there's what I wanted to do, I think. There, okay, I'm still messing with the technology. Thanks for your patience. We're almost done. Okay, so obviously this one needs to go up and left, right? So we're going to go translate. Up and down is y. So we're going to translate. Is it going up? Yes. And how much? 1, 2, 3. And it's going left. 1, 2, 3, 4, 5. Okay, and we can actually put that in terms of ordered pairs. We could say translate x minus 5, y plus 3. We could write it just like that. Now here's something that may come up, which is, hey, what if I go x minus 5 first, and then y plus 3? Well, obviously you end up in the same place. So you got to make a choice. But when we're writing it in notation, x is always going to come first in terms of notating it, okay? So you can travel whichever way you want to, but just make note of that you're moving x first and y second. In fact, that's a good habit to get into. So I actually think if you're always looking to go x and then y, that's going to match up better with how we notate it. There you go. There's our translations video done. All on one page. That was the goal. We used corresponding, we used vertex. We didn't use perpendicular in this video, and we talked about coordinates all the time. There you go. Stay tuned for the next video, part 2, rotations. Goodbye for now on the whichermath channel.